we're going to be looking at the thermal conduction through various types of material. We're going to look at the difference between insulators and conductors in the way they transfer heat between one area and another. What we have here is a Carl Zeiss light that has been modified to take a 50 watt quartz halogen bulb. There is a mirror focusing that light through a lens. There is a block of aluminium that has been machined into a cone and polished on the inside, so the light coming out of the end here is around about 200 times brighter than the sun. The sample in this particular case is a piece of wood, and as you can see, the temperature on the left hand side is now around about 108 degrees, whereas on the right hand side it's still only about 22-23 degrees. And the reason for this is that wood is an insulator. The electrons in the material are not free to roam around in the material. That is why they're an insulator, not just electrically but thermally as well. Nylon is another long chain molecule, again is an insulator, and as you can see, the temperature on the left hand side is climbing dramatically, while the temperature on the right hand side has barely changed at all. Or in other words, energy is not moving from one side of the material to the other. Aluminium is a conductor. You would expect to see a quicker transfer of energy from one side of the material to the other, and that's exactly what's happening. If the temperature was the same at both sides, there would be no energy transfer. Iron, like aluminium, is a conductor, but iron has got about twice the density of aluminium. That means that it takes more energy to heat up or to make the atoms vibrate more vigorously. Consequently, if you look at this, two things. One, there's actually a bigger temperature gradient between one side and the other compared to aluminium, and two, it is actually slower to warm up because you've got to put more energy in there to get the same temperature increase.